All right, now I'm going to be honest with you guys. This lesson, 2.6, when we get to the end of the year and we're reviewing everything we did all year, this is one of the ones that students look back on and think that this is one of the hardest ones. So prepare yourselves. You can do this. Solving absolute value inequalities. All right, our vocab word, an absolute value inequality is just when you have an absolute value and you have an inequality. So if you have the absolute value of x is less than 2, it means the distance between x and 0 is less than 2. If you have an absolute value that's greater than 2, it means the distance between x and 0 is greater than 2. So remember, absolute value is all about distance. If it's less than, distance is less than. If it's greater than, distance is greater than. So, solving absolute value inequalities. To solve an absolute value that's less than a number, solve the compound inequality. The positive value is greater than the negative, and the positive value is less than the positive value. So, to solve an inequality that's greater than C, you're going to solve it as the positive is less than negative, and the positive is greater than C. All right, one helpful way to remember this is less and great or. So if it's less than, it's an and compound inequality. If it's greater than, it's an or compound inequality. Less and great or. All right, first example, solve each inequality. So I have the absolute value of x plus 7 is less than or equal to 2. So less and, we're going to set this up as an and compound inequality. So I have x plus 7 is less than or equal to 2. And x plus 7 is greater than or equal to negative 2. All right, now we solve for x. So subtract 7 from both sides. I have x is less than or equal to negative 5. Subtract 7 from both sides. I have x is greater than or equal to negative 9. When I put this on a number line, I have x is less than or equal to negative 5. And I have x is greater than or equal to negative 9. It is an and compound inequality. All right, in part B, I have the absolute value of 8x minus 11 is greater than 0. So great or. I'm going to set up two inequalities. 8x minus 11 is greater than 0. And 8x minus 11 is less than 0. So now we solve for x. We're going to add 11 to both sides. Cancels out on the left. I have 8x is greater than 11. Now we divide both sides by 8. I have x is greater than 11/8, or 1 3/8, however you want to write that. All right, on the right side, I add 11 to both sides. So now I have 8x is less than 11, and divide by 8. X is less than 11/8. So when we set this up on a number line, you may have noticed I only have one number. And x can be both greater or less than that number. Notice what x cannot equal. X cannot equal 11/8. If we look back at our original problem, this makes sense because we said that the absolute value is like distance. So that means the distance between 8x minus 11 and 0 has to be greater than 0. That means it cannot be at 11/8. It can be anywhere greater than that, any number other than that, but it can't be at 11/8 because that distance would be 0. All right, so part C at the top is actually a continuation of example 1. So if you would like to pause the video now and try to solve this one on your own and then check it to see if you got it right, that would be a good idea. All right, it is a less than sign, so we're going to set up less and. We're going to set up two equations. So I have 2w minus 1 is less than 11, and 2w minus 1 is greater than 11, negative 11. All right, and to solve for w, we're going to add 1 to both sides. Cancels out on the left. I have 2w is less than 12. Divide both sides by 2, w is less than 6. On the other side, I add 1 to both sides. I have 2w is greater than negative 11 plus 1 is negative 10. Divide both sides by 2, I have w is greater than negative 5. We set this up on a number line. I have negative 5, I have 6. And w has to be less than 6 or greater than negative 5. It's less and, so the compound inequality is an and inequality, and it's shaded in between. It's the overlap. All right, example 2. Solve each inequality, graph the solution. Notice this note I have at the bottom. Absolute value is a grouping symbol. Undo every other operation first. So I notice a 2 outside of this absolute value. Before I solve the absolute value, I'm going to divide both sides by 2. So I'm going to rewrite this equation as the absolute value of c minus 1 is greater than or equal to 3. All right, and this is great OR, so I'm going to set up an OR compound inequality. C minus 1 is greater than or equal to 3, or C minus 1 is less than or equal to negative 3. To solve for C, we add 1 to both sides. C is greater than or equal to 4, or C is less than or equal to negative 2. We set this up on a number line. I have negative 2, I have 4, and it's going to be greater than or equal to 4, and less than or equal to negative 2. All right, part B has a couple of things we have to undo first. First thing we want to do is get rid of this 1. I'll rewrite it. 4 times the absolute value of 2x minus 5 is greater than 20. Next, we want to divide by 4. So now I have the absolute value of 2x minus 5 is greater than 20 divided by 4, which is 5. This is, again, a great OR inequality. So we're going to set up 2x minus 5 is greater than 5, or 2x minus 5 is less than negative 5. To solve for x, we have to get it by itself. First thing I'm going to do is undo this subtraction by adding 5 to both sides. So now I have 2x is greater than 10. And next we're going to divide by 2. So I have x is greater than 10 divided by 2, which is 5. And my other inequality, still going to add 5 to both sides. I have 2x is less than negative 5 plus 5 is 0. So now divide both sides by 2, and I have x is less than 0. And when we put this on a graph, on a number line, I have 0, I have 5, and x is less than 0 or greater than 5. There's no equal to, so we're not going to shade in the bubbles. All right, this part C is a continuation of example 2, so I encourage you to pause the video, try it by yourself, see if you got it right. I'm going to solve for C. All right, so notice that there is a negative 3 here. The first thing we're going to do is divide by negative 3. Hopefully you caught it. When you divide by a negative, you flip the sign. So when I rewrite this, I'm going to have the absolute value of x plus 3 is greater than negative 9 divided by negative 3 is 3. All right, and we set up 2 inequalities. X plus 3 is greater than 3, and x plus 3 is less than negative 3. Solve by subtracting 3 from both sides. I have x is greater than 0, and I have x is less than negative 6. Set up a number line. I have 0. Oops. Negative 6 is less than 0. All right, so when I set up a number line, I have x is less than negative 6, and I have x is greater than 0. I don't shade it in because it's not equal to. All right, quick notes for you. Solving inequalities recap. When we solve inequalities, one-step and multi-step inequalities, We followed the steps for solving an equation, reverse the inequality symbol when multiplying or dividing by a negative. So flip the sign when you multiply or divide by a negative, just like we did here, because we divided by a negative. If necessary, write it as two separate inequalities. Well, we have inequality 1, we have inequality 2. And absolute value inequalities, you undo every other operation first. Absolute value is a grouping symbol, so isolate the absolute value expression, undo everything else first. All right, some summary questions for you. When solving absolute value inequalities, what is the first step you need to complete? Well, you undo the absolute value last, so if there's any other operations going on, you have to do those first. How do you determine if an inequality will become a compound inequality using and? Next question, how do you decide if it will be or? Key wording here, less and great or. If it's a greater than or equal to sign, it's an or compound inequality. If it's a less than sign, it's an and compound inequality. And what is a way you can remember how to solve absolute value inequalities? Right here, less and great or.